Hello guys, this is Bhavesh and today we are going to talk about a very important and very interesting topic known as gravitation. Now, do you ever wonder why do things fall down when you drop them? Like your phone, right? So when you jump up, why you land on the ground instead of floating off into space? Why planets always revolve around the sun? And also why the moon revolves around the earth? To answer these questions, this video will make you enable first to understand the concept and then to easily answer all these questions. Okay, let's delve into more details of this very interesting topic known as gravitation. So what is gravitation? Gravitation is a natural phenomena by which all things with mass and energy attract each other. Anything, whether they are two balls, whether they are two planets, whether two any two objects, they will definitely attract each other. And that is because of the phenomena known as gravitation. Okay, and if you observe your daily life, gravitation is the most intuitive force that we experience every second of our lives, right? So as whenever you drop a ball from your terrace or anything that falls, it always coming down, right? So this is due to gravitation. So we know about the motion of objects. Okay, you have studied it in your previous classes. The motion of object happens because of the force. So definitely here also all these motions that are happening under gravitation should also be due to a force. This force that is needed to change the speed and acceleration of the motion of objects is known as gravitational force, right? So to make the planets go around the sun or to move moon around the earth, we need some forces, and that force is known as gravitational force. Okay, so the story here starts with Sir Isaac Newton in 1666, around 350 years back, when he was sitting under a tree and an apple fell on his head. That fall of apple on his head made him think, if this earth is attracting this apple, will the earth or do the earth also attract the moon towards it? So he inquired about it, he thought about it. Then he conjectured, right? Then he thought and gave a law that is known as universal law of gravitation that we are going to study in further slide. Now let us understand the universal law of gravitation. So what does the universal law of gravitation says? It says the gravitational force between any two masses will depend on two factors. That is the masses of the two objects and the distance between those two objects. Okay, let's take an example here. As you can see in this figure, let's say the mass 1 is m1 and the other mass is m2, and the distances between these two masses, let's say, is d, small d. Okay, so the gravitational pull towards each other, gravitational attraction between these two, will be directly proportional to the masses and inversely proportional to the square of distance between them. All right, so if you mix uh, these two proportionalities, what do we get is the gravitational force is directly proportional to m1 m2 upon d square. Okay, if you remove this proportionality, you get a proportionality constant, that is capital G, and it's a constant also known as gravitational or universal gravitational constant. Its value is 6.67 in 10 to the power minus 11 Newton meter per kilogram square. All right, so the formula that we get from universal law of gravitation is Fg is equals to Gm1 m2 upon d square, where Fg is the gravitational force, m1 is the mass of first object, m2 is the mass of another object, and d is the distance between them. All right, let's understand this universal law of gravitation with a very simple example of earth and moon. So these values that we are taking are real values here. So the mass of earth is 6 in 10 to the power 24 kilograms, and the mass of the moon is 7.4 in 10 to the power 22 kilograms. Okay, and the distance between earth and the moon is around 3.84 lakh kilometers. So what we want to know that how much force this our earth is exerting on the moon, that it is revolving around the sun. So as I discussed before, that the moon is holding in its place in its orbit because of the gravitational force. Okay, so how much is this gravitational force that is holding the moon in the orbit of the earth? Okay, so let's understand this with this simple example. It's a very simple example. Let's try to look at. So the if you observe the question, it has given the mass of the earth, mass of the moon, distance between the moon and the earth, and what do we need? The gravitational attraction of the moon towards the earth. That is a gravitational force between the moon and earth. So this F is basically G capital M small m upon d square, where capital M is the mass of the earth and small m is the mass of the moon, and d is the distance between them. If you put these all values between in the formula that we just derived in by the universal law of gravitation, this F will be is equals to G m upon d square. You have the value of G, that is a constant, 6.7 in 10 to the power minus 11, and capital M is 6 in 10 to the power 24, small m is 7.4 and 10 is to power 22 upon d square, where d is 3.84 in 10 is to power 5 kilometers. Just remember one thing, that you need to put the values in SI units. So kilometer will change into meters. So the value of the distance will be 3.84 in 10 to the power 8 meters. All right. If you put these values and do the calculation, as you can see in the figure, the force that you get between the earth and the moon is around 2 into 10 to the power 20 newtons, which is a very big force, which is holding the moon in its orbit around the earth. So I hope this video helps you in understanding the basics of gravitation, and I thank you for watching it. See you later.